everybody, Chad here.
And Lee here
From the Chad Show.
Boy, that's been a while.
It has been a while. So this is the how-to video that we're doing on the complete radio installation.
Yeah, exactly. Complete Futaba in here right now. High-tech 645s, majorly through here right now.
Yeah.
There's a couple oddball ones in the fuse. I think there's a quarter scale servo for the elevator. I can't remember what the throttle servo was in there. But
Yeah, it doesn't matter.
It's all coming out.
Yep, it's coming out. Lee's got some much needed maintenance he needs to do to this. Part of it is fixing some control linkages that have loosened up over time through the hours and hours of flying. So we figured we figured it was a perfect time to do the radio swap. Reason we chose this plane also is Lee's super comfortable with it. He knows exactly how it flies, so he'll be able to tell if there's any difference, negative effects from the stuff that we put in, or positive effects.
Yeah, exactly. I mean, it'll be a really good test bed.
Yeah.
And that's something you want when you're switching over from something completely new to yourself.
Exactly. And in the springtime, once he takes it out, we'll find out what he thinks of all the stuff. I've used all the stuff already. Lee has not. So this is all brand new to Lee.
Exactly. I can't see anything but positive coming out of it. Some cool new features that will be going in it will be a gyro for one.
Exactly.
Into it, so.
And we'll get into more detail on the stuff, but we'll list off at least what we're putting in it. Like you said, we're doing a gyro. We're putting in a Spectrum radio with one of their new receivers, power safe receivers with telemetry built in.
Put into it.
A lot of cool features with that we'll get into.
This one will be running 2 battery packs.
Yep, you're doing a high voltage, right?
High voltage.
Yep.
So there'll be 2 of those. I'm doing a hard shell case, which I've been told works out pretty nice.
Yeah.
It's not needed, but it's kind of a nice feature.
It gives it a little more assurance if something happens, you know. I mean, they have that hard case.
Yeah.
Even just a screwdriver slip.
Yep. Oops. And we've all done that.
So, but yeah, and we're putting in Spectrum servos. We'll explain why we chose the servos that we chose.
And so everybody knows, nothing is sponsored on this airplane.
No,
as far as stuff going into this.
We have paid for everything, so don't think this is a plug for Spectrum. I mean, I truly believe in Spectrum, and I've been talking with Lee, and Lee is starting to buy into it also, understanding the things that I'm telling him that are different with the other stuff.
Yep.
You know, some advantages. So yeah, that's...
And like I say, I've had no ill effects with Futaba or anything like that. It's, after all the talking we've done, I think I want to try it.
And we are using some non-Spectrum components as well.
Yes.
We got some stuff from Boom RC that we're installing on it. The switches are from Boom RC.
And I met them this year in Jonah.
Yep.
And they're very cool. Very cool guys to deal with too. I mean, they... Other than a cool accent.
Yeah.
So.
That's a chick's dig.
Yeah, exactly. Can't understand a word they're saying, but.
But from what I understand, if we go there, the Australian chicks dig the American accent.
I think that was a lie.
Yeah. He wanted to make us feel better.
Yeah, he did.
But, so yeah, we're going to get down and dirty on this. We'll start with the wing, move on to the fuse, and then into setting everything up. Like I said, we'll explain more in detail on the components as we come across them.
Definitely. So it's needed some maintenance for a while. I'm sure a lot of people have seen it fly. It's been that way for 2 years. So
all right.
Yeah, that was our biggest comment this year was, hey Lee, your cowl's loose when I get ready to fire up and leave. So
it's when it's not loose that you have to worry.
That's when I get scared. Well, see it shaking.
So enjoy the video. Hope you learned something. Thanks for watching in advance.
Yeah, definitely.
And,
thanks for continuing supporting us. You know, with the likes and shares and everything else too, man. And please comment on the videos and stuff like that.
All right.
See what you like.
Let's get started.
Let's do it. Hey everyone, Lee from the Chadley Show. Just doing unboxing some servos here to start assembling them for the Stuka swap out radio wise. I've got here a Spectrum A6150, which I'll be using in my flaps on the Stuka. Unboxing it here, some nice things I'm seeing here right off the get-go. the screws that are supplied with them are actually the standard socket head servo screws that a lot of people buy upgrades to put in for the servos. I know I do for the Futaba and the high-tech stuff that I've got. I never really used the Phillips screws that they come with.
Yeah, the Phillips screws tend to strip out.
They do.
You got one of them, Lee?
I got one laying right there.
All right, let me zoom in on that.
Zoom in on them, but I haven't used since I've come across the servo screws with the hex head in them. I have not used any of my Phillips screws in years. Just because it's so much nicer to be able to put them in and out with the ball driver, or even like you'll see me in the video. I got one set up in my drill that I actually pull them in and out. But yeah, that's a nice touch as far as that goes. Also for the servo arm, it's actually a hex head machine screw for going in the servo arm. And that's a really nice feature too, because like the high techs, they are Phillips also, so you get the Allen head with that. So some nice features I'm seeing.
Yeah, the problem with the Phillips in the servo is once you Loctite them.
Yeah.
You know, and then you try to take the arm off again.
Exactly.
So you get a lot more torque out of those. It's nice.
Definitely. One thing I did, over the years, I never really Loctited my servo screws going in. I would use canopy glue, just so it wouldn't lock in there too hard. But still, I mean, the Phillips head screws can strip out fairly easy if they've been in there for a while.
Another tip you can use if you do Loctite them and you have a Metal Gear servo, you're going to be Loctiting it. If you use your soldering iron and just heat up that screw a little bit, it'll soften up the...
There you go. There you go. Which, a lot of times, if you're out of the field or something like that, you may not have a soldering iron if you needed to pull that off. But anyway, here and there. So anyway, and they also give you a nice little internal tube washer to go in there to help with that, to keep it in place. So that's a nice feature too. So one thing we did want to talk about was actually assembling the servos with the grommets and the spacers in there. The grommets are actually a square grommet, and they actually have a spacer in there. That spacer will actually go through where the opening is, where you slide them in. So basically that slides right on into there, and that makes sure it's nice and flat. I'm going to go through and put them all in there real quick here, just to show you what we got. And when we get ready to put the spacers in, I will give you a little tip on that. So there we go, all four of the rubber grommets are in. Now the spacer that they got here, which you'll notice that they have a flat washer like on one side, and then it's just a straight tube on the other side. This end down here with the washer goes down towards the wood, away from the servo screw itself. And the reason being, as it's sitting in there, you want your screw head to go down through here. And what that does, this washer, as you tighten down that screw, is going to lock it against the wood. And basically the screw will tighten up against here, which will allow that rubber grommet to be able to move, let the servo move a little bit for vibrations and what have you. If you turn around the other way, you'll actually drive this portion right down into the wood, which will lock the servo up, and you lose your vibration control on that. So there's a neat little trick as far as getting these in here. Take a little screwdriver and just slide it right on in there. Done.
And you can actually load them all up at one shot.
I'll do the last three with all of them loaded up in there. There's 2 and 3.
That's way easier. You can use a pencil too.
Yep.
But this is super easy and convenient.
1, 2, 3. They're done. That's how easy that was. I've done it years, for years, doing it with thumb, trying to fight it, dropping it, looking for half an hour, trying to find that little piece. Where this, you're in control of it now, so it makes it a lot nicer. And like I say, when you put that screw in there, now you got a washer on that servo screw. So now as it goes in, you got the washer on the bottom of this now. Now that servo actually has some room to play in there a little bit for vibrations and torque and whatnot. So that works out nice. So
All right.
one down, several more to go, and we'll be ripping out old ones and putting in new ones.
Let's get them all put together, and then we'll start throwing some stuff in the wing, eh?
Sounds good, bud.
All right.
See you in a bit.
Hi everybody, Chad here from the Chadley Show. Going to talk about the servos we're using for the ailerons. These are the Spectrum A6220s. The reason we chose these is for the low profile for one, not as big of a necessity, but we're putting a gyro in this airplane, so we wanted a fast servo because with gyros you want the fastest servos you can get. This has a speed of 11 hundredths to 60 degrees, so that's it's mediocre. You can get them faster than that, but for this plane that'll be plenty fast. For the gyro we're using, that'll be plenty fast. Obviously the faster the more gain you can turn up, so the more stabilization control you can have for the windier days. So that's the reason we chose these. It's the same with the 6150s that Lee talked about just before, with the screws that come with it and the control horn screw. So yeah, it's a great servo. So we'll get these put into the wings and do some fast forward super speed stuff for you.
Superman stuff.
Yeah. All right.
See. All right, guys, we're back. Got the servos made up for the wing here. So we got all four of them ready to go. Next thing I'm going to do is we're going to get the arms set in here, just to make sure that they are set in center where I want them for, especially for the ailerons there, so we get equal travel. I'm just going to throw the horn on there right now just to see where it's going to show up. Got a nice little tool here. It's from Electrodynamics. It's the EDR 203 servo sizer. Basically, it'll find your center of the servos. It'll cycle the servos on a nice sweep, or it'll go hard end-to-end point on it. It also, for setting up and stuff like that, it's a really nice unit to have. I've got an old A123 pack from Electrodynamics. This pack was involved in a crash. It still works. I'm not going to trust it to an airplane, so that's the reason it's marked bench only. So that's the reason it's here. So I'm just going to plug this in. We got light showing the center right here in the yellow. So now I'm going to plug in my servo in here. And right now it's saying center. I usually like to go work it all the way through, and then come back and actually hit both buttons, and that gives me dead center. So now it's showing me where my servo is at dead center. So now I'm going to pull this back off and relocate the center. Now they do have an auto speed on here, so it gives you a nice slow speed sweep all the way through from 100% to 100% travel, or you hit it again and it'll go from hard end point to hard end point, 100% travel. And then if you hit both buttons here again, it'll go back to center. So now I know my servo is centered out, ready to go into the plane, so I don't have to guess at where it's at, especially in a situation like this where it's mounted to a hatch, which is going to be going in place, so it's not as easy to get to my servo horn to change that. I mean, I can leave these 4 screws out, pull it out, and move it around, but this just makes it a little bit more easier. So once again, that was from Electrodynamics. Servo sizer works great, so it definitely helps aid in setting up radios and servos and everything. So that's what we got right now. So we're gonna go through and make sure they're all centered where we want them to be. So we'll go from there.
You ready? Ready. All right, so we're back.
We are here.
Got the radio equipment installed in the fuselage now and the wing.
Yes.
You can see it was a very tight fit for everything.
We got it in there though.
I worked super hard on it.
All 3 minutes.
But
I had a director.
So, I mean, just real quick, we have the servos up here. That was in the stock location. All we did was swap those out.
I did have to make a plate for there was a quarter scale servo in there, so I had to make a plywood plate.
Yep, and we'll show that.
Yep.
We'll zoom in on it in a little bit here. But outside of that, everything else was moved or replaced or whatever, right?
I've got a box of entrails that you wouldn't believe.
Where is that?
I think it's in the other room. Let me grab
Don't worry about it. We'll show that
We'll do that later.
Yeah. And now we're back from the entrails.
There you go.
Or maybe we're not. I don't know. It
It
depends
could
how
be.
I edit it. So, 2 batteries here. Receiver and
Gyro is buried down inside.
gyro's buried down in there.
We got the one-click connectors.
Yep. The
Switch we haven't mounted yet.
Yep, we haven't mounted. We need to get an extension. There's a couple extensions we need to put in yet, but we can show you everything
That
as
we've got,
is. Yeah, it would all work like this.
Yep.
The wing, it's just the wing, servos in the wing, and a couple of wires coming out. So we don't really need to show that in grave detail.
We didn't think you guys really wanted to see actually putting a servo in and screwing the 4 screws in.
Yeah, it would
It's
have been
pretty
like
basic.
a 4-hour long video.
Yeah.
So yeah, now let's fade out into a close up of this with the magic of editing. All right, so we're back. You can see close up of everything. Lee, you want to kind of point out where you placed everything, and then after we do that, I'll go through and explain why it is where it is, kind of.
Sure. Basically, we got 3 servos up here. This one is actually our throttle servo, and that's an A6150. Next one up is going to be our elevator servo, which is an A6220, and A6220 on the rudder servo right here. So, moving back, this basically the servo leads running through here. I've got some spiral wrap. I can probably put a post up on that if somebody wants that stuff. Here's one of our satellite receivers. You got the direction going that way. Chad will explain that. Then we got our 2 battery packs here, both Velcroed in place. Couple of extensions running back to the receiver. Once again, our 1-clicks. Now, one thing we did on the 1-clicks here, when we made it up, we took 2 packages of them. That way now we cannot get the wrong one to the wing. So we got 2 of them in there. So, and basically that's it. So, moving on, we have buried down inside of here is the gyro. And we actually put a little plate down there for it. We also, inside of underneath the batteries here, we ended up putting a light ply plate with Velcro in there and a stop. Down inside of here, we also have another satellite receiver. And Chad will explain those here. So, 2 battery packs fit in there nice and snug. You'd think a Stuka would be a lot bigger fuselage than what it is, but it's not.
It's not.
It's not. And then obviously we got our AR-12-310T receiver. So,
Which this is a typical small area that you find on the 5th scale.
Oh,
World
yeah,
War IIs,
definitely.
You know?
Definitely.
So it is a lot of stuff to put in there, and by all means, World War Ones and the half scale stuff and stuff like that is way easier.
Oh yeah, you're kind of starting to shoehorn stuff. And this one in particular, this is a retrofit into an existing plane.
Exactly.
If you were building your plane and you got your components, you can do a lot better layout than this. This one does have, it's not a full cockpit in it, but it's got a majority of a cockpit. So it eats up a lot of the room in a small, in a small fuselage. So.
All right, so I'm going to explain starting from this side, working my way this way, I guess. Throttle servo here, we would normally, I'd normally suggest using a small one just because it takes up less space. This was already opened up for a standard size servo, so we used a standard size servo. Normally I would use the 5060, which is a smaller, it's a mini servo, not a micro servo, but a mini servo. The biggest thing with the throttle is you can't use just a regular super cheap one like a 425 in an installation like this, a high-tech 425. because you need something that's high voltage.
Exactly.
It doesn't have to be an expensive servo, but it needs to be a high voltage servo. It needs to be able to accept up to 8.4 if you're using the lithium or the LiPo batteries. If you're using life batteries, then you can use whatever you want.
Yeah.
And then we have elevator and rudder. Those we use the A6220s. We use those because they're a fast servo. It's not the fastest servo out there, but you want as fast a servo as possible that you can afford because of the gyro. Once the gyro's over here. Yeah. With the gyro, you want to use as fast a servo as possible because when you're going through the air and you have the gyro on and you hit a burble, your gyro senses that instantly and sends it to your servo. Your plane's only going to react as fast as your servo. So the gyro is going to sense it. It's going to send it to the servo. If you have a fast servo, it corrects it right away. If you have a slow servo, you hit it, and then it takes the servo time to move the control surface.
It's kind of like driving drunk.
Yeah, so now it really doesn't work.
Yeah.
I've tried using this gyro on with 645 servos, the high-tech 645s, and they're just too slow. I couldn't really get any good benefit out of the gyro.
Yeah.
So that's why we chose those servos. You can get faster servos than this. We use these because I had them at my shop. I had already purchased them. So instead of spending a whole bunch of money, we were able to use something that we already had. But if you get something in like the 11 hundredths, 10 hundredths, the 0.1 area or faster, that's the most ideal. And then get back here, we have the two LiPo batteries. Don't need a huge C rating. 20 C is plenty. We chose the 5,000 milliamps for less times we have to charge.
Yep.
Because we want to pull these out every time we charge. We want a lot of milliamps, so once the plane's together and we're at a show for 3 days, we don't have to charge every day.
Yeah.
And pull the plane apart to pull the batteries out.
Yep.
If you're using lifes, you can leave the batteries in and charge. You do want to make sure you balance though, so make sure you can access your balance leads on a life. Then we have the one clicks. Lee talked about those. I don't really have to go into any more detail on that. That works just like a regular extension for a servo. It's just a matter of what the end of the plug looks like. And then we have our receiver. This is the Power Safe receiver from Spectrum, the AR 310T. Dual battery inputs with EC3s, which is convenient because the power draw that you're using, you don't have to worry about not having a thick enough wire or enough lead going into your receiver. So it has the telemetry built in. We don't have any of the telemetry modules set up, the sensors set up. Just like this, it will sense your voltage in your receiver pack. It will sense how many milliamps is being pulled out of that, that kind of information. But you need to get a sensor if you want to temp your engine, if you want to see your RPM. They have airspeed sensors. They got a bunch of different sensors out there. So if you're an electric guy, you can get a amp draw on your electric motor and also where your power is at on your electric motor, your voltage. So you get both of those separately. Did you have something to add?
On this one, I'm using an old standard Magneto G62. The RPM sensor only works on a electronic ignition?
Correct.
Okay.
Because it plugs right into the tack lead that comes out of like RCXL ignition.
Yep.
And I think every engine that I've ever used that was electronic ignition had that tack lead on it. So Lee's trying to find one, but whatever. So you can just stop that, Lee. There we go. Okay, so here's the ignition.
Does that one have it?
This one doesn't have it. we'll edit that out.
But yes, I got one right here.
All right.
Stupid Velcro. Edit
All right.
that out.
All right, so the receiver also has the different satellites. The advantage of the different satellites is you have 3 satellites, and then you also have an antenna from your receiver. That's basically like having 4 receivers in your airplane. I'm not going to get into all the politics on that, but I find that a very comforting thing, that I have to lose reception to 4 receivers before I lose reception to my airplane.
There you go.
Now, with the satellites, they have the little ends here. These are the antennas. This is a field tubing from Robart.
Airline.
Or, my bad, yeah. This is an airline from Robart. And it's perfect size. Cut it about 1.25 inches, 1.5 inches, and you can maybe...
Not enough Red Bulls or beers.
Oh, boy. Oh, boy.
I have a couple comments I can say, but I'm
You
not
can
going
slide
to.
it over, and then it goes right onto the little plastic end that sticks out of the satellite
housing.
here. And what that does is it keeps these from vibrating and breaking off. And then you can also put a little plastic dip that you can get at a local hardware store. It's what you use to put on your tool handles.
Yeah. Cushion
And
them.
yeah, just use a little acid brush and dab a little bit in here. That'll keep these from vibrating and breaking. Normally, if you have a Spectrum receiver that doesn't get the bind right away or takes a while or keeps losing the bind, it's your A satellite. The A satellite is the one that holds the bind. Now this one is built right into the receiver, the A is.
Okay.
So it starts with your B and then your left and your right. But the A satellite, replace that line on your A satellite, the lead, and I would be willing to bet that it's going to hold your bind great again. These, I like to replace these every couple years.
Okay.
Just because.
It's a small wire.
Yeah, I mean, they're just a couple bucks.
Yep.
It's well worth the insurance.
Exactly.
So that's that.
If you notice, we only have 2 of them in right now. I'm waiting for another extension.
Yeah, we need to get an extension. So we have this receiver. The antenna for the receiver is going down at a 45-degree angle. Then we have another satellite down here. You want to try and keep it as high in the airplane as possible. Now this is upside down, so it's down low, but the further away from the ground you can put your satellites, the better they work when it's on the ground because of the interference with the ground. So that one, the antennas are going this way. All right. And then we have another one here. The antenna's going this way. And then the one that we put up there, it's going to go at a 45 again, 90 degrees to this one. That way, the way 2.4 works, it's a straight line, so you'll always have at least one signal that is not a straight line. It's impossible to, with the way you orientate them, to have them all where you can lose a straight line signal with all of them, which would only happen for a fraction of a second, and you'd probably never notice it, but why not? You have the advantage of having that many antennas. Use them.
Exactly.
And you don't have to use all the receivers. I recommend doing it, but it's not required for the Spectrum receivers. But it's just that much more insurance for $20. Yeah, for $20, it's a great insurance. So that's the orientation of the satellites. Then with the PowerSafe receiver, it also has the soft switch. And we've talked a little bit about this, but it basically, right now it's completing the ground, completing the circuit, so the receiver's off. Normally when a switch fails, which a switch is super common to fail, that's one of the most common failure points in the electronics of your airplane, it will fail into open position. If this were to fail or accidentally become unplugged from the radio for whatever, or the receiver for whatever reason, all it does is turns on the airplane. Now it's not going to do anything because my transmitter's not turned on, so it just goes into failsafe right away instantly. But so that's the advantage of this pin, and it's just basically a metal pin to complete the ground. You can use this switch. They have a regular switch that comes with the receiver, a flip switch that you're used to. And then you could also just use a bind plug or something of that sort. All you have to do is the signal has to go to the ground wire. Is how the switch works.
There you go.
Now we'll move on to the gyro. The gyro is buried down in here. It's tough to see with all the wires. But this is basically what it looks like here. So it's got your gain on the top. It's got a rudder input, 2 elevator inputs, so if you're running 2 elevator servos. It's got 2 aileron inputs, so if you're running 2 aileron servos. And then the respective ones over here. There's a USB port. You can buy the USB port or you can buy a Bluetooth one. They'll both plug into there, but that's how you'd program it on the computer. If you're not going to orientate it this way, say you're going to put it in the plane this way, you would have to change that setting in the gyro. Same with if you mounted it this way or this way. So as long as one end, you can't mount it at a 45 either way, so it has to be squared up with the fuselage.
Thrust line or whatever.
Yeah, so
or datum line.
So we have that. I use the iGyro 3E. Simply, it's the one that was taught to me in the beginning. The reason I stuck with it versus going over to the Cortex and stuff like that is I know people that know this gyro.
Yes.
So if I have any issues, I can call them and ask them. If I go to a gyro that I don't know and don't have anybody that can help me, it's not the best situation. I recommend that everybody uses what their club, unless you feel comfortable doing it, because there probably are some advantages to other gyros that this one doesn't have, and vice versa. But this one I can adjust each gain separately for the rudder, the elevator, and the aileron. It does have a heading hold function. I don't really use the heading hold functions ever.
I know we played with it that one day.
We played with it just to see what it did. I didn't care for it. I'm fine with just the stabilization and correcting if my plane rocks a little bit and the stabilization doesn't bring it exactly to where it was. I'm okay doing the rest of it, but to help, the stabilization basically makes it fly like it's in a low wind or no wind scenario. And you can listen to episode 5 of the Chadley Show. We're going to be talking about gyros and why you use them, the different reasons you use the different functions, stuff like that. So I won't get into it too big. That's a whole nother tutorial in itself. So that's what we have in there. And then, did I miss anything?
No, we got all the satellites, got servos, got 2 battery packs.
Yeah.
So we got 2 5,000 milliamp packs, so we got 10,000 milliamps.
Yeah, so that'll fly a crap load of flights with this.
Hey, John, Cease, just so you know, this is almost like flying an electric airplane for me.
Yeah. So, and granted,
happy birthday, John.
Granted, we don't have these completely strapped in yet because we wanted to show you the plates and stuff like that. You want to make sure that you have this stuff easily removable. There will be more strapping to actually physically hold it to the plane, more so than just the Velcro. But yeah, outside of that, try to make it as clean an install as possible. One thing I do want to note, the antennas, you want to try and keep, and it gets tough in an area like this, you want to try and keep them as far away from the batteries as possible, from the fuel tank, from the ignition system, all that kind of stuff. I think they recommend 3 inches.
Yeah.
You want to try and adhere to that. You aren't always going to be able to do it, but the beauty of the Spectrum telemetry, and I'm sure there's another company that does the same thing, I would guess. I haven't seen it with the top brands that I've dealt with. But the Spectrum will tell you if you're getting a hit, if you're getting interference, stuff like that, how well the receivers are picking up the signal, I guess.
Gotcha.
And it has 3 different ways it tells you if you're losing just on one satellite, if you're losing all the satellites for a second or whatever, and then if you actually get a hit to where you don't have any signal that it's picking up for a second.
Gotcha.
It will tell you those in different numbers so that you know if you actually lost signal to your airplane, if you lost signal to every satellite at the same time for just a split second, but it wasn't enough to make you not have
Yep.
or if you just have one satellite that maybe needs to be repositioned a little bit better because you have a carbon tube or something that may be interfering with it, or it may be too close to the battery, or whatever the case may be.
There you go.
So yeah.
Yeah. So cool.
Outside of that, the wings, the big thing with the speed of the servos is just on the channels that you're hooking up to the gyro. So if you have just a rudder gyro, a single channel gyro, which you can get, and you have it on just the rudder, you only need a high speed servo for the rudder then.
Okay.
The other ones can be regular, but if you go with a high voltage setup, everything has to be high voltage.
Yep.
And I know Futaba has receivers that are not high voltage, so you need to make sure you have a high voltage receiver. Spectrum, all the receivers are high voltage.
Okay.
So that's another thing. If you're a Futaba user, make sure you're using the high voltage receiver as well. Make sure that your gyro can handle high voltage.
There you go.
Every component that you have needs to be able to handle it.
One thing I don't think we touched right here. This is airline for the antennas.
Yeah.
Yeah, I literally glued that
Yeah,
to the side of the
the
fuse.
same thing as what we used on the satellites.
Yep. It just helps out with
Yep.
it. So
Another thing I do want to mention, the iGyro, this gyro can be mounted any location in the airplane. It does not have to be on the CG like some gyros do. I've actually mounted one of these in my tri-pacer that you guys have all seen fly.
Yep.
I had the gyro mounted by the tail.
yeah.
I mean, it was like a foot and a half away from the back of the stabilizer.
There you go.
And it worked like a champ like
Yeah.
that. So I've installed these way off the CG, as far off as I could basically, and it still worked
Still
great.
picks it up. There you go.
So you have to make sure with the gyro you're using, if you need to make sure if you need to mount it on the CG or not.
Yeah, you prep for it.
Yep. So outside of that, I mean, we made some plates for stuff to mount on, like Lee said. This one here for the receiver. We got some for the battery so that it supports the battery the whole way. The satellites we just have mounted with Velcro. That's plenty sufficient. You can use like a foam tape if you want.
Yeah.
Works great. The receiver, this specific receiver has shock mounts for it to bolt onto. A lot of them I just use Velcro or double-sided foam tape for that also. I like the Velcro because I can pull it out to work on the wires if I need
Yes.
to, stuff like that.
Verify wires are in and everything.
So yeah.
So
Outside of that, I think that covers everything that we did here. The wing is the same thing as this, basically. So
yeah.
this is the heart of everything.
Yeah. Like I say, still got to mount the switch. I'm trying to come up with where I want to put it at.
Yeah.
That's the only thing. So.
Yep.
And
So yeah, what we're going to do now, we're going to actually get in and check to make sure that our servos are going the right way on the gyro. We're going to make sure that the everything is working in the proper direction, and then we will come back and talk about the programming, how to program all of this stuff into the radio. So we'll get set up for that, and we'll be back.
all right.
All right, so getting ready to set up the model profile on the radio. Turn it on. We already have it bound. I'm not going to show that. The binding is fairly simple, and it differs a little bit per receiver. So go into system setup. It's going to ask you or tell you that your RF is going to be disabled. Ask you if you're sure you want to do it. Click yes. I'm already on the model. If I wasn't, I would hit model select and pick whichever one I wanted. And then the type, we're doing an airplane, so we'd click that. I already have that done, so I don't need to do that. If you're doing a sailplane, you would pick the sailplane. The model name, right here you just use the roller to do what you need to do. We'll name this one Stuka. Alright, so we have that named. hit the back button. Aircraft type, this is where you pick the wings. So we're doing 2 ailerons, 2 flaps, but you have your normal with 1 aileron. That would be like on your trainers with the bell cranks or torque rods. Then you have your dual ailerons if you have or a servo for each aileron. You have flaperons, where if you're going to allow your ailerons to work as flaps also. You have 1 aileron servo with 1 flap servo, 1 aileron, 2 flaps, 2 ailerons, 1 flap, 2 ailerons, 2 flaps, and then you have elevons if you're doing like a delta wing. Elevon B, I'm not 100% on what the difference is there. And then you have 4 ailerons, 6 ailerons. This would be for like your aerobats when you have 3 servos per aileron. We are doing the 2 ailerons, 2 flap servos. Then you have your tail. If you're running a V-tail, dual elevator servos, single rudder, dual rudder, single elevator, dual rudder, dual elevator. We're running just a single on each, so we click the normal. And then next you have, if you're running some of the AS3X gyros, we're not going to be doing that with our gyro. Our throttle mode is going to be normal. It's not reversed. Engines, this is where you pick how many engines you have on a multi-engine. We have 1. So we have that set up. Then you have your flight modes. We're not going to be doing anything with flight modes. We don't really need that on here. Channel assignments. This is where you can pick which switches you want to do what things. So here's for auxiliary 3, we have the right lever. On the back side, it's the slider. Auxiliary 4, we're using the left one. Auxiliary 5, we're also using the right one. We just have that set up. All the bombs will drop with the right lever. So, trim setup, we're not going to worry about that right now. Model utilities, that's if you're gonna create a new model, stuff like that. We're not worried about that. Warnings, this is if you start your radio with the throttle in the up position. When you turn your radio on, it will tell you that the throttle's in the up position and make you pull it back before it sends signal to your airplane. It works good for your landing gear also. If you have a landing gear switch, to make sure that when you turn on your airplane, your landing gear doesn't go up. So that's a nice function. Telemetry, this is where you set up the different telemetry you want. We're using the RX pack. It automatically selects the RX voltage and your flight log. And then you can go into the settings here. If you want metric or US, we're obviously US. And then you can pick the display, how you want the display to be done. I always leave it on roller so I can scroll through everything with the roller easily. File settings. This is where you can change the file name that it saves it at if you have your SD card in. And then when you want it to start, it can be on. You can start recording it with a switch. You can have it so that when your throttle goes over 25, it starts. We will have it on the throttle one. So once we get over 25% throttle, it'll start recording the data. And the reason you do that is when you take off, you go above 25% throttle, it starts recording the data. You don't need to record while you're starting the airplane or any of that stuff. One time, you want to make that active. That way, when you pull back behind 25%, it doesn't stop recording. So if you did say, I don't know, if you had it on a switch that is a switch that you do during one of your checks, you could set it on that and make it so that make it so you can turn on and off, so it only records, say, when your landing gear's up, and then when your landing gear comes down it doesn't record. I don't know why you'd want to do that, but that's what that's for. And then we want to enable that it's on. You want to make sure that you record that. That way if you ever have an issue, you can go back, pull that out, load your information on the laptop, and see all that. And then pre-flight setup is if you want to do a check, say you have a sliding canopy that you want to make sure is locked before every flight and all that stuff, you can put all that stuff in, receiver battery test, stuff like that, so that you have to check your battery. You have to say that you checked your battery. You have to click through it all. Frame rate, we're not going to worry about that. Binding, that is different setup for that, per receiver. This is if you want to set up your trainer, the wired trainer, wireless trainer, and then the different alerts. The rest of this stuff is kind of more on the advanced side. We're not going to get into that too much. The other thing is a transfer SD card. If we had this in, I could transfer my different models to that card so that I can load it in another radio, or vice versa, load it into this radio. Alright, so that's starting up the main things. Now we'll get a little bit more work done on the airplane, and we'll come back and show you how to set up the flight controls and stuff. Alright, so I am going to show you how to bind it real quick. With this receiver, there's a button for binding also, right here. So when you start it up, you'll click and hold this button, pull the pin, and then on the radio, when you turn the radio on, I'm already on the Stuka profile. I'll press and hold the trainer button and then turn it on with all that going. So it's kind of a two-handed project. So first thing I'll do, press and hold, pull this out. You see the light flashing, that's showing it's in bind mode. Now I'm pushing the trainer button and I'm going to turn it on. And if Lee stays on the screen, it'll go through its bind.
DSMX 22 milliseconds. Entry. Bind complete.
Alright, bind's complete. I can let go of everything. I had the flaps down. So now it's bound. Everything's bound. We're going to center the fuselage back, and we'll show you how to put the servos, make sure all those are going the right way and moving the proper amounts. So we'll be back. Alright, so now what we're going to do, make sure everything's going right. We'll click the roller. That brings us into our screen. We're going to servo setup. So that brings me in. I have my travel, my sub trim, my reversing, my speed. We're not going to worry about the ABS travel or about the balancing. We don't need that on this model. That's more of an advanced thing. We will work with the speed on the flap servos. We'll work with the reversing if we have to, and sub trim if we have to, and travel if we have to. Now I have some of this preset just to make it go a little bit faster, because you don't need to see it on every single servo or surface. So we're going to start with the elevator here. If you notice, it's got a little bit of down elevator in it right now. So I will go to the sub trim on here, scroll over to the elevator servo, click on that, and then I'll just start rolling. Now it's giving it down elevator, and it says down on the radio to also the D in the end. I don't know if you can see that.
Yep.
So I was going the wrong way. Now I'll go back, and Leo pointed on there. If you want to tell me when it's good, Lee.
More right there.
Right there. All right, so that's set. I'll click the button again to get off of it. Now I can move. So now my elevator set there. It's moving the proper way. Now we'll move on that set, and that is that enough throw there? It looks like enough to me. All right, so now we'll move on to the rudder. We'll check the rudder. I always like to stand behind it, and I drive the plane. So I give it left rudder. My rudder's reversed, so I'll have to go in and reverse the rudder. I'll go back up to my main one here and pick. I want to go to reversing, and I just want to make a note, we already have the throttle set and bound properly, but if you ever have to reverse your throttle, you always want to rebind it right away. After you're done programming your whole airplane, I still recommend rebinding it also.
Okay.
That just saves all of your fail safes so that it's in the proper spot. All right, so we'll go to the rudder here, and we'll click on that. Now the rudder is reversed in the right way. It looks like the sub trim's off a little bit, eh, Lee?
Quite a bit.
We'll go back to the sub trim. Go onto the rudder again. Click on there. I need to go to the left, but I'm going to the right. So we'll go to the left. Tell me when, Lee.
Right there.
All right. So I have that set. Throw looks good to me. Look good to you?
Yes. Yes.
And you can put a gauge on there and make it so it's exactly the same, and you would do that with your travel. Once you have your sub trim, your throw or your sub trim, you're reversing all that set. So we already got the ailerons done. As you can see, those are moving good. We have those throws set right. The flaps we put on the slider. We have those going, but as you see, they move super fast. So we'll go into the speed, and we have 2 flap servos. So you'll notice that number 5 is left flap, and number 7 is right flap. And you can set it so that, I'll do this, I'll set it so that, we'll exaggerate it, 3 seconds. So when it goes down, or when it goes up on that one, it's going to go up slow. So you can have it so that it only goes slow one way, or you can have it so that it goes slow both ways. And if you look, I have the right flap so that it's still at the normal speed. So you can see that I'm jamming the throw all the way, and it just slows the servo down.
So you want to make sure on something like that make sure you got both of them set correctly.
Yep.
Otherwise, you're going to have to like an aileron in the dirt.
Exactly. So we'll set this one at 3 as well. And they both move together. If I move it just halfway, it'll go just halfway at that speed. I can go the rest of the way. I can go partially up at that speed. That just makes it a more smooth transition to flaps. Now, a lot of people want to try and do this on their elevator or something like that if it's sensitive, and I'll show you the issue with that. If I set my elevator up, say we'll really make it go, and we'll put it at 9. So it's going to take 9 times as long, I think, is what it's set up. And that's fine because it moves nice and fluidly, right? But now I have full up. I want to come out real quick. I can't come out real quick. It doesn't allow it to move fast.
Yep.
So that's not a replacement. If you need to slow because it's too sensitive for you, you want to do that in Expo. And we're not going to worry about Expo on this plane. If you want a tutorial on that, you can ask for a separate tutorial on the other things, and we can get more into detail on that. But never change the speed on your flight control surfaces. Flaps, it's great. Also, throttle. Never do it on your throttle either, for the simple fact of if you need to abort a landing real quick and you go full throttle, it's going to take a long time to get up to full throttle.
Yep. Be like turbine.
You know, you just move it slowly if you have to move it slowly. There's nothing that can replace that. So don't misuse the speed for the wrong thing it's meant for. So we already have the throttle set. We have the aileron set. We have the flap set. We will get the gyro ready to show you how to check to make sure that your gyro is moving the right way, and we'll show you the differences between what heading hold and stabilization looks like. So let us get set up for that, and we'll start another recording.
Alrighty.
Alright, so now we're going to check the servos, or check the gyro, make sure everything's moving the proper way. We already set it up so that it was. I don't want to go through and keep pulling it apart during the video to show you how to change that. We can do that in a different tutorial. Radio's boot all the way up. It's on Stuka. I'll pull it out. The gyro's going to set. You heard it go. That means that the gyro's set. Alright. And now I have the gain turned all the way up. We may not fly it like this, but it's the easiest way to check it because it's going to be the most dramatic. And I also have it on the heading hold. That's also the easiest way to see it. So when I lift, when the tail comes up, you want the gyro to make the tail go back down. So you see how the elevator goes up? When the tail comes up, elevator goes up, that's going to push your tail back down. Alright? The rudder's the same way. When the rudder moves one way, you want it so that it pushes that tail back. Can you see that moving, Lee?
I think we can.
Alright. Otherwise,
Yeah.
Alright.
No, we're good.
So it's moving the right way, and basically what it is as the tail comes this way, the rudder kicks over, and that pushes the tail back to center.
Yep.
Alright? I don't like to put a heading hold ever on this, so it's programmed right now so the rudder can never be in heading hold. Reason for that is when you're going around the corner, if you accidentally have it in heading hold, it's going to try and do a flat turn to go back the original direction when it first went into heading hold. So that's why that automatically went back and didn't work in heading hold. Now, the ailerons work. Let me reset them here. Alright. When the wingtip comes up, you want the aileron to come up so that it pushes your wingtip back down. As you see, it's working. When the wingtip comes up, the aileron goes up. That way it comes back down. And that's on the heading hold. Now I'm going to turn it to just the stabilization. And now you'll notice that when the wingtip comes up, the aileron's going to come up, but it's going to go right back down, even though I'm holding the wingtip up. And what that's meant for is as the wingtip comes up, it's going to push it down and stop. If it doesn't go all the way down, you have to finish it the rest of the way. That's just to even out the burbles in the air. So you can see it went up, come right back down. Now it's going to go down and go right back up. And that's stabilization. As you see the difference between stabilization and heading hold, you go up, the aileron's staying up until it goes back to that original position. Whereas the stabilization, the aileron goes up and goes right back to center. It doesn't stay up like it does in the stabilization, or in the heading hold. So that's the major difference between stabilization and heading hold. I don't use heading hold a whole lot. I just use the stabilization just to even out the burbles in the air. So that's making sure that everything's correct on your gyro. Make sure that your controls are moving the right way. If the wingtip comes up and your aileron goes down, and make sure you check both ailerons. If it goes down when your wingtip comes up, it's going to try and roll your plane even further, which therefore it's going to put more throw in because the gyro is sensing that it's not enough. And it's really going to be hard to handle. I know this because I set one up wrong once. Oops. So that's that.
that's pretty much the end. Now it comes down to throttle curves and setting your throttle points that you want, what you really need to run the engine. We're not going to get into any of that. All right, so got everything set up now.
Yep.
For the most part, we did a real basic to give you the idea of setting up. We didn't want to get in too much detail specific to this airplane because we wanted it to be more of a general thing.
Yep.
So
Things went smoothly. I mean,
Yeah.
we had a lot of fun doing it, so
Yeah.
it took a little extra long time and whatnot.
well, that's what it's about, having
Exactly.
fun. So, and there again, if you guys want us to go in more detail on a certain aspect of the radio, like I said, I have a DX20, a DX9, Lee has a DX8, DX18. He has a Futaba that he's pretty good with. So, I mean, even if you need a Futaba tutorial, Lee can do something like that, showing you how he does stuff. So if you want something more in-depth, in detail on one of those specific things, we have access to that.
Yep, definitely. We'll try to help you out as much as we can.
And-
if not, we'll get the information to you somehow.
Yeah. Whether we just write something up for you, we may not be able to do a video if we don't have the actual stuff there,
Yeah.
but we can write up a description,
Yeah.
something like that.
And if we gotta BS you, we'll BS you, but we'll tell you that we're BSing you.
Yeah.
So.
We'll always give you an answer.
Yeah.
But we may have to tell you that don't listen to us.
Yeah.
So, like I said, hope you enjoyed it. Look for the Stuka flying this year.
Oh yeah.
And I'm sure after Lee takes it for a few spins, he will get on the video and tell you what he thought about Spectrum versus his Futaba, the pros and cons of both of them.
Yeah, definitely. I just ended up getting a new GoPro, so you'll be seeing some in-flight photo or video and stuff like that. And so we'll be posting videos from flight lines and on airplanes and a little bit of everything. So.
I'm thinking about putting my GoPro in my Newport in the canopy.
There you go. There's going to be a camera in the 39 in the cockpit area.
Fantastic. So look forward to those videos, guys.
Thanks for watching. Thanks
Yeah.
for supporting us and whatnot.
And let us know. Keep topics for the podcast. Keep topics for how-to videos and stuff like that coming. We will try to get to all of them if we can, and we will do them in order that makes sense based off of what we have going on at the time.
Exactly. And if we miss any of your comments or suggestions or anything like that, remind us. I mean, we are human, and we have crap load of stuff going on.
Yeah. We're not social media experts.
No.
We're not professional videographers.
No, by any means.
So we're just modelers trying to help you all out.
Exactly.
I know. And with that being said, see ya.
guys.